The rate of an exothermic reaction, so the reaction is exothermic, that means heat energy is released, is followed by measuring the concentration of the reactant. So here it measures the concentration of the reactant at regular time intervals. During the experiment, the temperature of the reaction mixture is not controlled, so the temperature can vary. Given that the which graph shows the concentration of the reactant against time. So which graph shows the concentration of the reactant? Since reactant are at a higher concentration at the start of the reaction, so D would be wrong since the reactant is 0. So the reactant would have a higher concentration which is given in A, B and C, but the answer would be B because if we divide the reaction in 3 parts, that is at the start of the reaction, as the reaction proceeds, and at the end of the reaction. So for this graph we can see that as the reaction starts, the concentration of the reactant starts to decrease. As the concentration of the reactant decreases, the reaction occurs, and as the reaction occurs, the reaction is exothermic. That means heat energy is released to the solution. Since heat energy is released to the solution, that means temperature of the solution increases. And as the temperature of the solution increases, therefore more collision occurs between the reactant and the rate of the reaction increases. And as the rate of the reaction increases, more reactant are being used up. Therefore, the concentration of the reactant starts to decrease at a higher rate. Then again, at the end of the reaction, as most of the reactant are being used up, therefore the rate of the reaction starts to decrease. Again, at the start of the reaction, reactants are at a higher concentration, therefore the rate as the reaction occurs, the concentration starts to decrease. As the reaction occurs, the reactant concentration starts to decrease. And as the reaction occurs, as the forward reaction is exothermic or the reaction is exothermic, that means heat energy is released. Since heat energy is released to the solution, that means temperature of the solution increases, and as the temperature of the solution increases, therefore the speed of the reaction increases. And as the speed of the reaction increases, that means more reaction occurs and more reactants are being used up. As more reactants are being used up, therefore the concentration of the reactant starts to decrease at a higher rate. Therefore the graph would be steep. Then at the end of the reaction, we can see that there is less reactant at the end of the reaction since most of the reaction has already occurred. Therefore at the end of the reaction, since there are less reactant, therefore the rate decreases, and so the rate of decrease of reactant also decreases. Therefore decrease in concentration also decreases. Since there are less reactant, so less reaction occurs, thus there is less decrease in concentration of the reactant. So initially at the start of the reaction starts, the reaction occurs at a higher rate, then reaction occurs at a lower rate since reactants are being used up.